Hi everyone, so welcome to the third video of statistics. Let's see the learning objectives of today's lecture. First of all, we will see what is actually a normal distribution. Then we will see the functions of normal distribution. Let's move forward. A probability function known as the normal distribution is used in statistics to describe the distribution of data values. An essential probability distribution utilized in statistics is the normal distribution. Because of the benefits it offers in real-world situations, it is the most significant probability distribution function employed in statistics. For instance, population, height, shoe size, IQ level, rolling the dice, and many others. So what is actually a normal distribution? It is generally observed that the data distribution is normal when there is a random collection of data from independent sources. The graph produced after plotting the value of the variable on x-axis and count of the value on y-axis is bell-shaped curve graph. The graph signifies that the peak point is the mean of the dataset and half of the values of the dataset lie on the left side of the mean and other half lies on the right part of the mean, telling about the distribution of the values. The graph is symmetric distribution, just like I have mentioned earlier. Some important points of normal distribution are given below. The mean and the standard deviation serve to describe the normal distribution. Because of its shape, the normal distribution is frequently called a bell curve. The majority of the values are centered. Equal values for the mean and the median. It only has one mode. It decreases equally to the left and the right of the center since it's symmetrical. Probabilities for the data are represented by the normal distribution's area under the curve. 100% of the area under the entire curve R1 is present. Let's see the functions. R has four inbuilt functions to generate normal distribution. They are described below: D-norm, P-norm, Q-norm, R-norm. Let's see the first one. The R programming language D-norm function estimates the density function of a distribution. The height of the probability distribution at each point is provided by this function for a given mean and standard deviation. Let's see its syntax. You just have to use the keyword of D-norm, then provide the variable, mean, and standard deviation, where var is a vector of numbers and represents the dataset of values. The mean of the dataset is represented by mean. The sample's data average value 0 is its default value. The standard deviation of dataset var is represented by SD var. The default setting is 1. Let's move to RStudio. Let's say first of all, I have a variable dnorm var, and this vector contains a sequence of values from, let's say, -5 to +5. And the values are incremented by 0.1. All right, so it's time to make a variable with the name of result1. And here I will use the dnorm function. All right, and inside this function, I will pass my variable of dnorm var, and I will say take the mean of dnorm var and also the standard deviation of d norm var. Then I will say plot. This function is used to see or visualize the results. So I will say plot the d norm var on x-axis and the result 1 on y-axis. Let's run it. So you can see the result right here. This is a normal distribution and you can see the height of your observations. The data set is decreased from both sides, left and right. And the x-axis of d norm var contains the value from -5 to 5, which are incremented by 0.1. And on the y-axis, it contains the result. So this is how you can use the d norm function. Now let's move back to slides. Next, we have p-norm function. The likelihood that a random number x will have a value less than or equal to x is measured by the p-norm function, which is a part of the cumulative distribution function. Cumulative distribution function is also another name for p-norm function. The syntax is as follows. Just use the p-norm keyword, pass the variable, mean, and standard deviation, where var is a vector of numbers and x represents the dataset of values. The mean of dataset is represented by mean var. The simplest data average value, 0, is its default value. The standard deviation of the dataset is represented by SD var. The default setting is 1. Let's see how we can implement this in RStudio. First of all, I will create another variable with the name of pvar, and this variable contains a sequence of values from -5 to 5, and they are incremented by 0.1. Here I take a variable with the name of result2, and I use the pnorm function, and I say take the pnorm var variable and find out the mean of pnorm var, and also take the standard deviation of pnorm var variable. In the last, I say plot the pnorm var variable on x-axis and result2 on y-axis. Let's run it. So you can see your output right here. Now you can observe here that the probability of the random number is less than the given number. All right. Now let's move back to slides. Next, we have qnorm function. This function is the inverse of the pnorm function. It uses the probability value as input and outputs a result whose cumulative value is equal to the probability value. It is helpful for determining a normal distribution's percentiles. The syntax is quite simple. Just use the qnorm keyword and pass the parameters, where the mean of the dataset var is represented by mean var. The simple status average value is 0, which is the value by default. The standard deviation of dataset is represented by SD var. The default setting is 1. P is a probability vector. Let's implement this in RStudio. Now, first of all, let's create a variable with the name of qnorm var, and this variable contains a sequence. Now here I gave the values for probability. Let's say it can either be 0 or it can be 1. in y equals to 0.02. And here I create a variable with the name of result 3. I use the qnorm function, and this function will give me the output of the values that will match the corresponding values of the probability value, which I have given above here, 0 and 1. So first of all, let's pass the qnorm var variable, and I say take the mean of qnorm var and also the standard deviation of qnorm var, and I say plot, take the qnorm var variable and then the result 3. All right, let's use it. So you can see the output right here. These are the probability values according to the y-axis. This is how you can use the qnorm function, pnorm function, and dnorm function. Let's see the last one. In our programming, a vector of random numbers with a normal distribution is produced using the rnorm function. The sample size is used as the input, and that many random numbers are produced. To display the distribution of the generated numbers, a histogram is created. The syntax is as follows. Just use the rnorm keyword and pass the parameters, where the mean of the dataset is represented by mean and then var. The simplest data's average value is 0, which is the default value. The standard deviation of dataset is represented by SDVAR. The default setting is 1. The number of observation is n, which represents the sample size. Let's move to RStudio. Well, first of all, I will say result for, and inside this variable, I will use the rnorm function, and I say create random 1000 numbers, take the mean as 5, and standard deviation as 3. And next I say create a histogram and take the result for variable, and here I say breaks equals to, let's say I want to create breaks of 50. Let's run it. So you can see your histogram right here. You have breaks of 50 and you had generated random numbers between 1000, and here is the frequency. Let's move back to slides. So here I have some little homework for you. You have to use all functions to find nominal distribution. You can assess the dataset length by clicking for once. Now good luck. See you next time.